In this video, we're gonna talk about trigonometric identities. We begin the lesson with a definition of an identity and a conditional equation for equations involving circular functions. An equation that is true for all values of the variables for which every term of the equation is defined is called an identity. Otherwise, the equation is referred to as a conditional equation. For instance, the equation x times the quantity x minus 1 is equal to x squared minus x is an example of identity since it is true for all values of x for which the involved expression is defined. When x is equal to 1, both sides are equal, that is, 0. When x is 20, both sides are also equal to 380, and so on. So for whatever values of x, the expression is defined, and that is what we called identity. If the equation is not true for some values of x, then we say that an equation is a conditional equation. For instance, the equation 2x plus 6 equals 12 is a conditional equation because it is only true for x equals 3. 2 times 3 is 6, plus 6 is 12. But when x is equal to, say, 4, the equation will not be true because the left side of the equation will be equal to 14 and the right side is 12. In other words, conditional equation holds true only if certain conditions are satisfied by x. Trigonometric identity is an equation involving a trigonometric function or a combination of trigonometric functions which is valid for all values of the variable for which the functions are defined. Trigonometric identities are verified using the so-called fundamental identities. From the definition of the 6 circular functions, the fundamental identities are derived. Recall that if point xy is on the unit circle, then cosine theta is equal to x, sine theta is equal to y, tangent theta is equal to y over x, secant theta is equal to 1 over x, cosecant theta is equal to 1 over y, and cotangent theta is equal to x over y. Note that the pairs cosine theta and secant theta, sine theta and cosecant theta, and tangent theta and cotangent theta are reciprocals. Hence, secant theta is equal to 1 over cosine theta, which is equivalent to cosine theta is equal to 1 over secant theta. Then, cosecant theta is equal to 1 over sine theta, or sine theta is equal to 1 over cosecant theta. We also have cotangent theta is equal to 1 over tangent theta, or tangent theta is equal to 1 over cotangent theta. These 3 identities are referred to as reciprocal identities. Take note, reciprocal of cosine is secant, reciprocal of sine is cosecant, and reciprocal of tangent is cotangent. Also note that since tangent theta is equal to y over x and cotangent theta is equal to x over y, they can be expressed in terms of sine and cosine. That is, tangent theta is equal to sine theta over cosine theta. Remember, x is cosine while y is sine. For cotangent, we have cotangent theta is equal to cosine theta over sine theta, x over y. These 2 identities are called quotient identities. Moreover, since xy is a point on the unit circle, then it must satisfy the equation x squared plus y squared equals 1. Note that x is cosine and y is sine. Therefore, replace x and y with cosine and sine respectively. Thus, we have cosine squared theta plus sine squared theta is equal to 1. Now, if we divide both sides of this equation by cosine squared theta, we will get 1. Cosine squared theta divided cosine squared theta is equal to 1, plus tangent squared theta. From our quotient identities, sine squared theta over cosine squared theta is equal to tangent squared theta, equals secant squared theta. 1 over cosine squared theta is equal to secant squared theta from our reciprocal identities. Hence, we have 1 plus tangent squared theta is equal to secant squared theta. On the other hand, if we divide this equation by sine squared theta, we get cotangent squared theta, cosine squared theta over sine squared theta is equal to cotangent squared theta, plus 1 Sine squared theta divided sine squared theta is 1. equals cosecant squared theta. 1 over sine squared theta is equal to cosecant squared theta. Recall that sine is the reciprocal of cosecant, or cosecant is the reciprocal of sine. So we have another identity, cotangent squared theta plus 1 equals cosecant squared theta. These three identities are called Pythagorean identities. Examples. Simplify each of the following. Number 1, cosecant theta minus cosecant theta times cosine squared theta. The good thing about knowing identities is that we can use them to simplify a complicated expression involving circular functions. Number 1, we can factor out cosecant theta. So this is equal to cosecant theta times the quantity 1 minus cosine squared theta. Then, from the fundamental identities, we can find the value of 1 minus cosine squared theta. We use this identity cosine squared theta plus sine squared theta equals 1. If we transpose cosine squared theta to the right side, we have sine squared theta is equal to 1 minus cosine squared theta. So 1 minus cosine squared theta is equal to sine squared theta by Pythagorean identities. Moreover, we can also rewrite cosecant theta to 1 over sine theta. By reciprocal identities, cosecant theta is equal to 1 over sine theta. Then, we cancel out sine. Here, we have 2 sine theta. We cross out 1 sine theta, so we still have 1 sine theta. And 1 times sine theta is equal to sine theta. Another example. Simplify sine theta plus cosine theta quantity squared plus sine theta minus cosine theta quantity squared. So this is equal to this expression. First, expand sine theta plus cosine squared theta quantity squared. This means to multiply sine theta plus cosine theta 2 times. Distribute, we have sine theta times sine theta is equal to sine squared theta. The exponent is written this way. You should not write it this way nor this way, okay? Then, sine theta times cosine theta is equal to cosine theta times sine theta. Next, cosine theta times sine theta is also equal to cosine theta times sine theta. Then, cosine theta times cosine theta is equal to cosine squared theta. Combine cosine theta and sine theta, thus we have 2 cosine theta times sine theta. Just copy sine squared theta and cosine squared theta. We do the same process with sine theta minus cosine theta quantity squared. Nag-iiba lamang sa sine. From this, we can cancel out 2 cosine theta sine theta. So we have sine squared theta plus cosine squared theta plus sine squared theta plus cosine squared theta. Take note that cosine squared theta plus sine squared theta or sine squared theta plus cosine squared theta is equal to 1. So sine squared theta plus cosine squared theta is equal to 1 from Pythagorean identities. And 1 plus 1 is 2. So that is how we simplify an expression involving circular functions. We can also use the fundamental identities to establish or prove other identities involving circular functions. Verifying trigonometric identities is not like conditional equations. Remember, do not cross-multiply the sides of trigonometric identities. Below are some tips on how this can be done. Number 1, start with one side of the equation. We begin with the more complicated side. 2, manipulate this side to arrive at the expression on the other side by using identities. 3, if possible, write the entire equation in terms of one trigonometric function or in terms of sine or cosine. Ito ang pinaka-lowest term sa trigonometric identities kung naka-sine or cosine ang equation. Examples. Prove the following identities. Number 1, sine theta times cosecant theta over cotangent theta is equal to tangent theta. We start with the left side of the equation. We write cosecant theta to 1 over sine theta by reciprocal identities. Cosecant theta is equal to 1 over sine theta. Then, cross out sine theta. We have 1 over cotangent theta equals tangent theta. Recall that 1 over cotangent theta is equal to tangent theta. Reciprocal of tangent is cotangent, or reciprocal of cotangent is tangent. Thus, sine theta times cosecant theta over cotangent theta is truly equal to tangent theta. Another example. Number 2, 1 minus secant theta over sine theta minus tangent theta is equal to cosecant theta. We express the left side of the equation in terms of sine and cosine. Secant theta is equal to 1 over cosine theta, reciprocal identities, while tangent theta is equal to sine theta over cosine theta, quotient identities. Secant theta is equal to 1 over cosine theta, and tangent theta is equal to sine theta over cosine theta. Then, find the LCD. In the numerator, LCD is cosine. Simplify, cosine theta times 1 is cosine theta, minus cosine theta divided cosine theta is 1, times 1 is 1. In the denominator, we also have cosine theta as the LCD. Cosine theta times sine theta is equal to sine theta times cosine theta, minus cosine theta divided cosine theta is 1, times sine theta is sine theta. Then, we cross out cosine theta. We're then left with cosine theta minus 1 all over sine theta times cosine theta minus sine theta is equal to cosecant theta. In the denominator, notice that we can factor out sine. So, this will become cosine theta minus 1 over sine theta times the quantity cosine theta minus 1 is equal to cosecant theta. There's a common factor in the numerator and denominator, which is cosine theta minus 1, so we cross it out. The equation then becomes 1 over sine theta is equal to cosecant theta. Recall that the reciprocal of sine is cosecant. By reciprocal identities, 1 over sine theta is equal to cosecant theta. Number 3. Prove 1 over 1 plus sine beta plus 1 over 1 minus sine beta is equal to secant squared beta. Work on the side with fraction. Combine them and simplify. On the left side, find the LCD, and that is 1 plus sine beta times 1 minus sine beta. Simplify. Divide the LCD by the denominator of the first term. Here, we cancel out 1 plus sine beta. We're then left with 1 minus sine beta. Multiply it by 1, so 1 minus sine beta times 1 is 1 minus sine beta. Plus, also divide this by this. Here, we cancel out 1 minus sine beta and multiply 1 plus sine beta by 1. So 1 plus sine beta times 1 is 1 plus sine beta. In the numerator, we cross out sine beta. So 1 plus 1 is 2. Simplify the denominator, we have 1 times 1 is 1. 1 times negative sine beta is negative sine beta. Sine beta times 1 is sine beta. And positive sine beta times negative sine beta is negative sine squared beta. Cancel out sine beta, we have 1 minus sine squared beta. So, 1 plus sine beta times 1 minus sine beta is equal to 1 minus sine squared beta. Note that by Pythagorean identities, cosine squared theta, or in this case, cosine squared beta plus sine squared beta is equal to 1. Transpose sine squared beta to the right side, we have cosine squared beta is equal to 1 minus sine squared beta. So 1 minus sine squared beta is equal to cosine squared beta by Pythagorean identities. Then, we could write this as 2 times 1 over cosine squared beta is equal to 2 times secant squared beta. And notice that 1 over cosine squared beta is equal to secant squared beta by reciprocal identities. Thus, we have 2 secant squared beta, which is equal to the expression on the right-hand side of the equation. Number 4. Prove cosine squared x minus sine squared x is equal to cosine to the fourth times x minus sine to the fourth times x. Use factoring technique when necessary. So we factor out the right side of the equation. We have cosine squared x plus sine squared x times cosine squared x minus sine squared x. Then, recall that cosine squared theta plus sine squared theta is equal to 1 by Pythagorean identities. So this expression here is equal to 1. And 1 times cosine squared x minus sine squared x is cosine squared x minus sine squared x, which is equal to the expression on the left side. Another example. Prove cotangent theta plus tangent theta is equal to cosecant theta over cosine theta. Express the circular functions in terms of sine and cosine. Cotangent theta is equal to cosine theta over sine theta, plus tangent theta is equal to sine theta over cosine theta by quotient identities. Then, cosecant theta is equal to 1 over sine theta by reciprocal identities. First, simplify the right-hand side of the equation. So we write it as 1 over sine theta times 1 over cosine theta. We copy the numerator, change the operation to division, and find the reciprocal of the denominator, which is 1 over cosine theta. Then, find the LCD on the left side of the equation. We have sine theta times cosine theta. Simplify, sine theta times cosine theta divided by sine theta is cosine theta. Maga-cancel out ang sine theta. So we just have cosine theta. Multiplied by cosine theta, we get cosine squared theta. Plus, sine theta times cosine theta divided by cosine theta is sine theta. Times sine theta is sine squared theta. Equals 1 over sine theta times cosine theta. 1 times 1 is 1, and sine theta times cosine theta is sine theta times cosine theta. Again, recall that cosine squared theta plus sine squared theta is equal to 1. Pythagorean identities. So here, this is equal to 1. Hence, both sides are equal. Aside from the 8 fundamental identities, we also have sum and difference identities. Cosine of a plus b is equal to cosine a times cosine b minus sine a times sine b. While cosine of a minus b is equal to cosine a times cosine b plus sine a times sine b. So for cosine, if the given operation is addition, kung plus siya dito, ang operation naman dito ay subtraction. At kung minus, dito ay plus. This is cosine a, cosine b, then sine a, sine b. On the other hand, sine of a plus b is equal to sine a times cosine b plus sine b times cosine a. While sine of a minus b is equal to sine a times cosine b minus sine b times cosine a. Pag sine naman, kung anong operation ay yun din ang operation dito. Pag plus, plus din dito, at kung minus, minus din dito. However, pag sine, we have sine cosine, sine cosine. Dito, nauuna ang a bago b. Then, pagdating dito, we switch the values b and a. So sine a, cosine b, sine b, cosine a. Then, tangent of a plus b is equal to tangent a plus tangent b over 1 minus tangent a times tangent b. While tangent of a minus b is equal to tangent a minus tangent b over 1 plus tangent a times tangent b. Pag plus, plus din dito at dito ay minus. At kung minus, minus din dito at plus naman dito. So these are the sum and difference identities. This is also known as the general addition formulas. Examples. Number 1, simplify cosine of pi over 4 minus pi over 6. We can use sum and difference identities in solving problems involving circular function values of sum or difference of angles. So to solve for cosine of pi over 4 minus pi over 6, we use this identity. Cosine of a minus b is equal to cosine a times cosine b plus sine a times sine b, where a is pi over 4 and b is pi over 6. Hence, we follow this identity, we have cosine pi over 4 times cosine pi over 6 plus sine pi over 4 times sine pi over 6. Recall that pi over 4 has coordinates square root of 2 over 2 and square root of 2 over 2. And cosine is equal to x while sine is equal to y. So cosine pi over 4 is equal to square root of 2 over 2, the x value. Times, also remember that pi over 6 has coordinates square root of 3 over 2 and 1/2. Thus, cosine pi over 6 is equal to square root of 3 over 2, the x coordinate. Plus, sine pi over 4 is square root of 2 over 2, the y value, times sine pi over 6, which is 1/2 the y value. Simplify, square root of 2 over 2 times square root of 3 over 2 is square root of 6 over 4. Square root of 2 times square root of 3 is square root of 6, and 2 times 2 is 4. Plus, square root of 2 over 2 times 1/2 is square root of 2 over 4. Square root of 2 times 1 is square root of 2, and 2 times 2 is 4. LCD is 4. Simplify, we get 4 divided 4 is 1, times square root of 6 is square root of 6. Plus, 4 divided 4 is also 1, times square root of 2 is square root of 2. Thus, cosine of pi over 4 minus pi over 6 is equal to square root of 6 plus square root of 2 over 4. Another example, prove cosine of alpha plus beta plus cosine of alpha minus beta is equal to 2 cosine alpha times cosine beta. Copy the right side and simplify the left side. For the first term, we use this identity. A is alpha while b is beta. So this is equal to cosine alpha times cosine beta minus sine alpha times sine beta. Plus, here we use this identity. So this is equal to cosine alpha times cosine beta plus sine alpha times sine beta. Then, we cross out sine alpha times sine beta and combine cosine alpha times cosine beta. So we have 2 times cosine alpha times cosine beta, which is equal to the expression on the right side.